Hello everybody. Well, what I wanted to do today was just to present a couple of ideas about trigonometry. Now, in any triangle where you have a right angle like this one here, and you have a reference angle, remember which side is which. Now, straight across from the reference angle is the opposite side, which we abbreviate to O. Right next to the reference angle is the adjacent side, which we abbreviate to just A, and opposite the right angle is the hypotenuse, which we just abbreviate to H usually. Now there are three trigonometric ratios: sine, cos and tan, and they each are the ratios of different sides of the right angled triangle. Now sine of the reference angle is equal to the opposite side divided by the hypotenuse. Now some people remember the first letter in each of these formulas and call it so. Now other people write it like this, so they can remember the opposite on top of the hypotenuse. Okay, now you can also remember car, which is cos, C for cos, A for adjacent, and H for hypotenuse. So you can remember car, cos is equal to the adjacent over the hypotenuse, or you can simply remember this shape here with the adjacent over the hypotenuse. And for tan, tan is equal to the opposite of the adjacent. Now you could remember it to R, tan is equal to the opposite over the adjacent, or you could remember this device here. Now, let's have a look at the first problem. Find the following given the triangle. Now, if we have a look at this, we have the reference angle here. Now, this will be the opposite side. Right next to the reference angle is the adjacent side. And straight across from the hypotenuse, straight across from the right angle is the hypotenuse. So the opposite side is equal to 21, the adjacent side is equal to 28, and the hypotenuse is equal to 35. Now, we have sine here. Now, sine is equal to the opposite over the hypotenuse. So sine of theta will be equal to 21 over 35. Now, the adjacent, the cos angle here, well, cos is equal to the adjacent over the hypotenuse. Now, the adjacent side is equal to 28. The hypotenuse is equal to 35. So cos will be equal to 28 over 35. Now, tan is equal to the opposite over the adjacent. Now, tan of theta is equal to, now, O is equal to 21. That's the opposite side. And the adjacent, well, here it is here, is 28. So now we've written these in the form of numbers. So we can say that sine of theta is equal to 21 over 35. And you can simplify that if you like, because 7 goes into 21 and 7 goes into 35. So sine of theta would be 3 over 5. 7 goes into 21 3 times, and 7 goes into 35 5 times. And the others simplify as well. Okay, let's move on. Okay, well here we have another problem. What we want to do is for each of the following, sine theta, cos theta and tan theta, to figure out the trigonometric ratios given this triangle here. Now, from our reference angle here, this is the opposite side. Right next to our reference angle is the adjacent side, and straight across from our right angle is the hypotenuse. Now we know sine of theta is equal to the opposite divided by the hypotenuse. Now the opposite side is 9 and the hypotenuse is 41, so sine of theta is 9 divided by 41. Cos of theta is equal to the adjacent divided by the hypotenuse. So cos of theta, now the adjacent side is 40 and the hypotenuse is 41. Now tan of theta is the opposite divided by the adjacent. Now that will mean that tan of theta will be equal to, the opposite side is 9 and the adjacent side is 40. So tan of theta will be 9 divided by 40. let's try the next one. Well, what happens if we have letters here instead of numbers? Well, the same thing still applies. Which side is which? Straight across from our reference angle is the opposite side. Right next to our reference angle is the adjacent, and straight across from the right angle is the hypotenuse. Now sine is the opposite divided by the hypotenuse, which means that sine of theta is equal to x divided by z, because the opposite side is x and the hypotenuse is z. Now cos of theta is equal to the adjacent divided by the hypotenuse. Now that will mean that cos of theta will be equal to y, the adjacent side, divided by z, the hypotenuse. Now tan theta is equal to the opposite divided by the adjacent. Now the opposite side is x, so this will be x divided by the adjacent side, which is y. Alrighty, one more. Okay, find each of the following unknown solutions. So I want to find tan of theta, sine of alpha, sine of theta, sine of alpha, cos of theta, cos of alpha, tan of theta, and tan of alpha. Now let's see. For alpha here, I'll use blue. Now for alpha, this will be the opposite side, this will be the adjacent, and this will be the hypotenuse. For theta here, for theta, this will be the opposite side, this will be the adjacent side, and this will be the hypotenuse, and it will be the same. So remember, theta is in red, and for alpha, that's in blue. Alrighty, now let's see. Let's do red for theta first. Now for theta here, here's the opposite side and here is the adjacent side, and the hypotenuse is right across from the right angle. Now we're probably going to need to use some Pythagoras theorem here to work out the hypotenuse. So if you work it out, you can say that it'll be 33 squared plus 56 squared, which is equal to 65 squared, I believe. So the hypotenuse is 65. Now sine of theta will be the opposite divided by the hypotenuse. Okay, well the opposite side here will be 33 and the hypotenuse is 65. Now sine of alpha, well since alpha is over here, the opposite side will be 56 and the hypotenuse will be 65. Now cos of theta, cos is the adjacent over the hypotenuse. Now the side that is adjacent to theta is this one here, 56, and the hypotenuse 65. Now cos of alpha, now let's see, right next to alpha is the adjacent side, which is 33, over the hypotenuse, which is 65. Now tan of theta will be, here's theta here, I'll keep going in red, here's theta here, opposite it will be 33, and adjacent to it will be 56. Now for tan of alpha, straight across from it, the opposite side will be 56, and adjacent to it will be 33. Alrighty, well I hope that helped everybody, and I'll see you in class.